Hello and welcome back. Let's talk about one of my favorite types of differential equations, which is the homogeneous differential equations, which basically means we can have any function of y, y prime, y double prime, y quadruple prime, triple prime, anything, just not a constant, and that all equals 0. So basically an example of this would be the second derivative of y plus 2y prime plus y equals 0. So this is a homogeneous differential equation, and you might notice some similarity to I believe it's called a homogeneous solution in linear algebra, or homogeneous space, that's what it is. But anyways, that's not what we're learning about right now. But basically we don't have a constant, and if you have knowledge of linear algebra, you would understand that if there was constant over here, it'd be able to be brought over there. I mean, that's just general math as well. And so it has to equal 0, basically. And so what we can really think about this as is the second derivative of y plus 2 first derivative of y plus the 0th derivative of y, because for a regular y, we've derived it 0 times, so it's just the 0th derivative of y. And now, we're going to do a little trick. And so you can use any variable here. I like to use epsilon because I think it looks cool. So what we're going to do is we're going to take epsilon and we're going to just put it to the power of 2, plus 2. Epsilon to the power of 1 is 1, plus epsilon to the 0 is 1. And this all equals 0. And now we just solve for epsilon. What we're going to get is epsilon plus 1 times epsilon plus 1 equals 0. Or in other words, we have epsilon 1 equals -1, and epsilon 2 equals -1 as well. So now let's get into the general solution for homogeneous differential equations. Now, this might seem complicated at first, but it really isn't. We have the general solution y equals constant times e to the epsilon 1 of x, or not of x, times x, plus c e epsilon 2 x. See where we're going with this? Dot, 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 plus c e to the epsilon n x. Which basically means if we solved this polynomial and got 8 different values for epsilon, we'd have 8 terms here. Sorry, there's a plow going by right now. It's very snowy where I am. There, I think it's past now. Sorry if that interrupted the video. But yeah, so now we have our general solution. And for this case, we have y is c e to the, we have 2 negative x's, so plus c e to the negative x. And we can combine these terms, just get 2 ce to the negative x. 2 times c is just going to be another constant, so we get, we'll call this just c again. Now let's check our answer. Well, we've got a y double prime and a y prime in here. So y prime is going to be negative ce to the negative x using the power rule. No, not power rule, sorry, chain rule. And y double prime is just going to be the same as y prime. So let's plug it into our equation, check if we got it right. going to erase this general solution here. Let's plug it into our equation. Okay. So we've got y double prime, which is ce to the negative x, plus 2 times our y single prime, negative ce to the negative x, plus our normal y, which is ce to the negative x. And so we've got 2ce to the negative x's, and we've also got minus 2ce to the negative x's. Obviously, this is going to equal 0, and so we got the right solution. And this is really cool because, I mean, to get the general solution, we didn't do any differentiating, no integrating, nothing. And so that's what I think is really super cool about these. And I mean, I could show the proof, but who wants to know about the proof when you're never going to have to do it, right? So I think we'll only go over one example this video. So thanks for watching. I hope to catch you in the next one where we start getting a little more complicated. Really not that more complicated.